All right, so we're going to try another one here. You can probably assume that I have done one that worked, one that hasn't worked, and so maybe this might be one that's inconclusive. So let's take a look. So ratio test again says limit as n goes to infinity of the absolute value of the next guy over the current guy. So in that part, what's nice is that whole part you don't have to worry about because we're looking at the absolute value of it. So that just goes away. So I'm looking at, oops, put in limits here. N goes to infinity of the next guy divided by the current guy, which is the same as multiplying by the current guy upside down. Okay. Now, in this, nothing cancels. You want to cancel stuff, but you can't because they're all different things. So I currently have this as limit as n goes to infinity of n plus 2, n plus 1, and I'm going to just at least rearrange a little bit here. Okay. Now, and this, you can look at all of it and say, hey, the degree on top is basically n to the 3/2. The degree on bottom is basically n to the 3/2. So they're both the same degrees. There's no numbers out in front, so it goes to 1, which means this is inconclusive. Okay. But, so I have no idea what happens to this based off the ratio test. But if you look at the whole thing as a whole, okay, ignore, now let's stare at this alternating series part. It's definitely an alternating series. The terms, the degree on bottom is bigger, so the terms all go to 0, so it converges. Okay. So you know the whole series converges. The whole series converges. This question does not ask for absolute convergence or conditional convergence, so you do not need to worry about just looking at that piece. Okay? You don't need to worry about that. It just wanted to know the whole thing, what happened. So ratio test could not tell me if it was absolute convergent or divergent, but the alternating series test tells me it converges. So ratio test is very powerful, super powerful. Okay? But you don't always use it. When you know you should use it, or most likely use it, is when you see a couple specific things in your series. The thing that should trigger it for you is numbers to the n or factorials. Okay? So the reason is, in the green there, if you have a number to an n plus 1 over a number to the n, you're left with just the number. And the factorial part thing is if you have an n plus 1 factorial over an n factorial, you just get left over the n plus 1. So why the ratio test is nice with these things is you lose exponents in the green stuff, and you lose factorials in the blue stuff. And then you're only left with a basic fraction. Okay? So that's the key to ratio tests, and you'll see a lot more of it in the homework tonight. Okay? The root test is a little different style, okay? Used if you have a lot of things raised to the n, okay? Again, I mentioned this one doesn't happen a lot on the AP test, but when it does happen, you see it immediately, okay? The series will converge absolutely if you take the nth root of it all and look at that limit as you go to infinity. If it's less than 1, absolute convergent. The part here where it's less than 1 is that it's going to be the same style as what the ratio test was. So it diverges if you're greater than 1 or if you go to infinity. That's the exact same setup as the ratio test. And number 3 is inconclusive if it equals 1. So the only difference between the ratio and root test is the ratio test is taking the ratio of the next guy over the current guy. the absolute value of that. And the root test just says take the nth root and then look at it. Okay? So, the root test. It is a more generic version of the geometric series. I'm going to show that to you on this problem here. Okay? Determine the convergence or divergence of this. Now notice, there's a lot of raising to the n. So let me rewrite this a little bit and say this could be e squared over n to the n. Notice all I did was I kind of broke up that exponent and said e squared to the n. The reason I can do that, or want to do that, is now I have e squared over n all to the n. Since it's all to the n, we are going to do the root test. And with that root test, we'll say the limit as n goes to infinity of the nth root of e squared over n to the n. The nth root of everything raised to the n is just the stuff on the inside. And since n is going to infinity there, that goes to 0, which is less than 1, which is absolute convergence. Now, realize this part right here. This is basically the geometric series with an ever-changing multiplier r. Because you remember how the geometric series is a times r to the n? Well, in this case, that e squared over n, it's an r. That's the ratio part, what you're multiplying by every time. And that thing's changing all of the time because the n changes, so the ratio changes. So it's kind of a geometric series where that r thing that you're multiplying by needs to always be less than 1. If it's always less than 1, let me rephrase, not if the last one is less than 1, because that's where you're sending it to infinity, then you are converging. The last ratios way out there in this always ever-changing, evolving geometric series is less than 1. It's like going to 0. So the whole thing converges. Now, you can't do the sum stuff where it's like a over 1 minus r, because again, that r keeps changing. But I want you to think it's kind of like a geometric series that's always evolving. Okay? Let's look at this one. This is obviously the ratio test because it's raised to the n. So, or sorry, obviously the root test. Sorry about that. So, limit n goes to infinity of the nth root of 1 over inverse tangent to n. That just gets me limit as n goes to infinity of 1 over arctangent. If you remember, that is pi over 2. Visually, that's the tangent graph. And if you're looking at the arc part, it's saying, here's the thing that we only use for the inverse tangent. And when is that thing going to infinity? Right at pi over 2. Okay? So I got 1 over pi over 2, which is 2 over pi. Let's see. 2 over pi is less than 1. So, absolute convergence. Okay? So, let's take a look on the next page here. Okay? This is on page 631, and I'm going to have this, you're going to pause this in a second. There are 7 questions, okay? And I just want to know if things converge or diverge for each series, okay? There are 8 tools that we have learned so far, okay? Divergence test, geometric test, integral test, direct comparison test, limit comparison test, alternating series, and the two ones from today, the ratio and the root test. There's 7 questions. There are 8 tools, you know. You might use one tool all the time. You might use one tool once. You might never use a tool. But I want you to try these out. There's 8 of them. 8 tools, 7 questions. See if you can kind of figure out which ones are which. This might take you a little bit of time. This is good practice, okay? So I'm going to have you pause this. You're going to try it out. You can take a look at the answer key in the book. Just go to page 631 and look at those examples. Once you hit resume on the video, I'm going to tell you which ones I would have done, which tool for which. I won't necessarily go solve it all, but I would just at least tell you what I'm looking for or how I analyze things. Okay? So hit pause, try them out, hit play when you're done, and we can talk. All right, so staring at them, there's going to be some categories that I know exactly which test to use and I already know the answer. And there's going to be some that I know exactly which test to use, and I don't know the answer yet, but I know how to go get it. Okay? So, just staring at some of these, I think the one that screams at me the loudest is B. I'm going to label it with the number. I would use the geometric test on B. R is pi over 6, which is less than 1, so this converges. Done. This one screams at me, letter E screams at me because of that -1 to the n. So that, to me, is the alternating series test. Those terms go towards 0, and so they converge. Easy enough. Next one that's a little bit hidden because you guys always seem to forget the original first test is letter A to me is number 1 because the degree on top is 1, the degree on bottom is 1. So you only look at the numbers in front, and that's 1 over 3. Since 1 over 3 does not go to 0, 1 over 3 is not 0, you immediately know that this one diverges. Okay? So A, B, and E, Abe, I think you should see the test very clearly, and then you should already know the answer. Okay? The other 4, I think you should start being able to see which tests you need to use immediately, but then you actually have to kind of go do some work to figure it out. Okay? On C, I think it's the integral test. I think you can take this integral pretty quickly. X e to the negative x squared dx from 1 to infinity. It is just a u sub, which is nice. I don't really know the answer yet because it's improper and I need to kind of plug in the infinity to the integral part. But I know what I need to do. I need to do the integral. Okay? D, I am going to compare this to 1 over n. So that's going to be, now here's the debate. And we did this way earlier today in the warm-up. I want to compare it to 1 over n. 1 over n diverges. So I am hoping that the 1 over n diverges. So let me draw a picture down here. If I have that thing diverges, that means I want what? Above or below? What do I want it to be? I'm hoping the guy would be above it, and then I would know it diverges. If it's below it, I don't know what I have. And the big question is, I don't even know which guy's bigger. Which one's bigger, so I don't even know which case I have. So start realizing direct comparison test is good, and it's a good thing to picture and understand, but to play it safe, you probably want to go with number 5. Okay? The limit comparison test. That just plays it safe because you don't know which story could be told if you do the direct comparison test. I don't know the answer yet, but I know the steps I need to go do it, and then I should have it. What I'm hoping for is it diverges because 1 over n diverges, so I'm really hoping the ratio is a finite number, and then I can say they both do the same thing. Okay, F and G are the ones from the day. I told you the easiest one to ever see is the root test if you have everything raised to the n. So on number 8, this one should be the root test. Or sorry, on letter G, it should be the root test. And you know what? I think I'm going to clarify this one is a blue one. This is number 8. It's the root test. N over 2n, the degrees are the same, so it goes to 1/2. That's less than 1, so it converges. Because basically you can ignore the n and just look at the ratio part. Remember, it's like an evolving geometric series where the ratio is the thing on the inside, but realize that ratio is always changing. But the whole time, in the end result, that ratio is 1/2, which is less than 1. So it converges. Okay? F, to me, goes back to red. I know for sure it is the ratio test because it has the factorials and the numbers to the n, like I said on a previous slide. I don't know the answer yet, but at least I know the steps I need to go do to get it. Okay? So those are kind of all of the possible tests that you could use for this little 2-week sequence and series unit. Okay? Your homework is here, and yes, I made sure these are the correct homework assignments. Okay? Homework set in black, and you're getting used to the red set is just some good review problems. I'll be back tomorrow, and we have one more section to do. This section merges all of these tests that I've just taught you with my original chapter before spring break. It kind of pieces them all together, okay? So we're going to look at that, and then we'll start reviewing the rest of the week, and you have a test on this, most likely on Friday, okay? So we have one more thing on Tuesday tomorrow to do, then we'll review Wednesday, and we'll review Thursday, and you'll have your test on Friday. A summary of the test, just for your sake, some of you might like this. The summary of tests, all the different tests we learned, and the ways you can tell if they converge or diverge or how you use them. It's pretty nice little chart on page 632. You might enjoy that. From here, the video was about 20 minutes and 18 minutes, about 38 minutes. But there is a warm-up involved and those 7 questions on this video. So you're probably looking at, we are maybe 20 minutes left in class, which means you can dive into this stuff. So hopefully all this stuff works well, and I will see you tomorrow.